Hi everyone, welcome to our video lesson on rewriting quadratics from standard form into vertex form when a is not equal to 1. Go ahead and grab your notebook and pause this video, copy down everything that I have so far, and make sure you're taking notes along with us to be checked for homework tomorrow. So if you haven't already noticed, all of the examples that we did in the last lesson and in class were standard form of quadratics that started with 1x squared. And the completing the square process that transforms it into vertex form was very simple because of that a value being equal to 1. What I'm going to show you guys is the very similar method that we use to transform standard form into vertex form, still using completing the square, but now with a couple of slight tweaks to make sure that we take care of the fact that our a value might be something different. So anytime your standard quadratic does not start with 1x squared, you want to make sure that you're careful of that. You want to make note, and you want to use the extra steps that we're going to use today. Okay, so to start us off, I'm going to do the same exact thing we did in our last method. I'm going to move this constant over to the other side using the inverse operation. So this is going to say f of x minus 3 is equal to 2x squared plus 12x. Okay, now we're going to use our factoring skills in order to pull out that a value of 2 in front of the parentheses. But we have to make sure when we pull it away from the x squared, we also pull it out of the 12x. So think of it like factoring this right-hand side using the GCF of a. Okay, in this case, we're lucky 2x squared and 12x are both divisible by that a value 2. So I'm going to rewrite it with the GCF 2 on the outside, and then the two terms x squared and 6x that are left over when you divide by 2, and filling in on the left-hand side f of x minus 3. Okay, so that's like undistributing the a value of 2 so that it's now on the outside of the parentheses instead of involved with the 2x squared and the 12x. Okay, now the rest of the process is very similar to what we've done in the past. I'm going to go ahead and build a perfect square trinomial inside the parentheses with these two terms as my first two of the trinomial. So I'm going to put a blank space on the left-hand side to balance out the blank space that I'm going to need on the right-hand side that's going to fall inside the parentheses to give me that perfect square trinomial. Okay, same formula. We're going to take the positive 6 and we're going to use b divided by 2 squared. In this case, if our b is a 6, 6 divided by 2 is 3, 3 squared is 9. Okay, but hold up before you balance it out by writing a 9 on the other side. This right here is technically not a 9. When I put the 9 in this blank space, I have a 9 that will eventually be multiplied by a 2. Okay, so if you think about this entire right-hand side, we didn't just introduce a 9. We introduced a 9 that was going to be multiplied by 2. So on this side, we really introduced an 18. So to balance it out on the left-hand side, I have to fill it in with the positive 18 that I get if I was going to distribute the 2 to the 9 that we introduced. That's the step that most ninth graders miss when a is not equal to 1. So make sure you highlight that, star that. This is a big one. We're not going to be filling in the left-hand side and the right-hand side with the same number all the time. Okay, so on the left-hand side, negative 3 plus 18 simplifies to positive 15. And on the right-hand side, we can go ahead and factor this perfect square trinomial just like we have every other trinomial in the past couple of lessons. I'm going to think what multiplies to positive 9 that adds to positive 6, or I'm simply going to take half of the b term and then square the entire binomial. Okay. To finish it up, if I want it in vertex form, I want it to say f of x equals, so I'm going to go ahead and subtract the 15 back to the right-hand side. And this is going to say f of x is equal to 2 times x plus 3 squared minus 15. Okay, so not only does this tell us the vertex of the quadratic, which would be at -3, -15, but now we can also see that we have a dilation of 2, and we're going to have a parabola that's narrower than the parent function. Let me do one more example with you guys, this time throwing in a negative. So we'll call this number 1, we'll call this number 2. If g of x is equal to -3x squared plus 24x plus 10, we're going to go ahead and rewrite it in vertex form. Okay, so I'm going to move the 10 to the other side using the inverse operation of subtraction. If g of x minus 10 is equal to -3x squared plus 24x, okay, then I can rewrite this right-hand side undistributing the a value of -3, and I'm going to have it out in front of parentheses, factoring it like a GCF. So I take -3x squared, I divide it by -3, I'm left with that 1x squared we're looking for. If I take positive 24 and divide it by -3, I get -8, which is going to be attached to our x value. Okay, and then I'm just going to fill in the left-hand side. Did not change a single thing there. Okay. We're going to go ahead and build a perfect square trinomial. So on the left-hand side, we need a plus blank. That's going to balance out with the right-hand side plus blank inside the parentheses. And if you take this -8 here and put it into our formula, -8 divided by 2 squared, -8 divided by 2 is -4. -4 squared is positive 16. Okay, but remember, that's not really a 16. That's a 16 that's going to eventually be multiplied by -3. So if we want to balance it out on the left-hand side, do that multiplication, 16 times -3, and you get -48. All right, and this is one of the very few rare times that we're going to fill in our blank space with a negative number, but we do want to match it on the left-hand side with the true value of the right-hand side. So we're going to have to multiply the 16 and the -3. All right, from here we're going to combine like terms on the left-hand side. G of x is equal to, oops, sorry, not equal to yet, minus 58 is equal to -3 times x minus 4 squared, factoring that perfect square trinomial with whatever method works for you. And then I'm going to go ahead and add the 58 back to the right-hand side. So g of x is equal to -3 times x minus 4 squared plus 58. And this would be our original trinomial written in vertex form, which tells me that I have a vertex of 4, 58, and I also have a reflection and a dilation of 3 in terms of comparing this graph to the parent function. All right, so I'm going to give you guys 3 practice examples to try on your own. Okay, you're going to pause the video, you're going to copy down the 3 examples that I have on the next page, and you're going to try them out on your own to see if you got the hang of it. Okay, try it out now, and then if you get the right answer, awesome. If you don't, you can bring in your questions to class tomorrow. Okay, here are your 3 practice problems. Go ahead and pause the video and try them out for yourself. Okay, let's take a look and see how you did. Feel free to pause this video and compare your answers to mine. If your answers are different, then take a deep dive back into the work and see where yours started going differently than mine. Okay, if you have any questions that you don't understand or that you can't figure out, bring them into either extra help or class tomorrow, and we'll talk about a couple examples before we start practicing. Have a great day, everybody.